Hey there, class. Mr. Busky here. Hope you're having a good day so far. We're continuing with Chapter 7 with more right triangle stuff. Today we're talking about special right triangles. And so basically, special right triangles are triangles that have degrees of 45, 45, and 90, or 30, 60, 90. And they're pretty useful for trigonometry, which is a part of this chapter, which we'll talk about in the next few sections. But they are pretty useful for Algebra 2 and beyond. And so we are going to spend some time today doing that. All right, so we have a warm-up here. We have this the lengths of this triangle here. We're trying to determine whether it will make an acute, obtuse, or right triangle. So why don't you guys go pause the video. This is a review from 7.3. See how you, or yeah, maybe 7.2 even. See how you do. Yeah, it's actually from 7.2, my mistake. So we are going to, first we should see if it makes a triangle first. We didn't really talk about that, but what needs to be true for it to make a triangle? Well, the two smaller sides need to be bigger than the biggest side. So let's do that. What's 2 plus 9? 11. Is 11 greater than 10? Yes, so it is a triangle. Okay, it is a triangle. All right? And then we need to use a Pythagorean theorem. So a squared plus b squared and c squared. And we need to compare and see what kind of result we get. So a squared is, so the legs are the smaller sides, so 2 squared plus 9 squared, and then c squared is going to be 10 squared. 2 squared is 4, plus 9 squared is 81, and then 10 squared is 100. 4 plus 81 is 85, and 85 is less than 100. So is C larger or smaller than the other? Is C larger or smaller than the other, than the A and B? It's larger. C is larger. Oops. If C is larger, that means it's going to be obtuse. It's going to be a larger side. So this is going to be an obtuse triangle. All right, sounds good. Okay, so we're going to do some 30, 60, 90 triangles here. Let's talk, 30, 60, 90 and 45, 45, 90 triangles. So basically, all right, so what we do, these are basically like special relationships here, okay? So let's use red for this, okay? So the way this works is we have this 45, 45, 90 triangle, all right? So we have x, and x squared root of 2. So depending on what side is, the other sides are going to vary depending on that. So say x equals 5, right? This would also equal 5. What would this be over here? Well, it'd be 5 square root of 2, right? What if this were 13 square root of 2? If this were 13 square root of 2, then this over here would be 13, because it would be just the x, right? So it's basically like kind of a way to do a shortcut instead of doing Pythagorean theorem every time to kind of figure out like how they relate from that, okay? So in these blanks here, if we want to fill in these blanks, it's going to be square root of 2 over here, and down here is going to be twice. Oh, we got to talk about 30, 60, 90 triangles now. So basically, I think the 45, 45, 90 is a little bit easier because it's just x. It's x, and x square root of 2. The 30, 60, 90 is a little bit trickier. So across from 30 is going to be x. That's going to be the short leg. The hypotenuse is going to be 2x, and the long leg is going to be x squared root of 3. So what if we said that this was 7, x was 7? Well, this would be what? Down here, the long leg would be 7 square root of 3. And then 2 times 7 would be the hypotenuse, which would be what? It would be 14, okay? So it's basically a way to just kind of relate the sides based on, if you're given one side, you can kind of use the relationships to kind of figure out the other sides without having to, like, do other weird stuff, okay? So over here, we're going to put square root of 3 and 2 and square root of 3. I don't really like the way they word this, but that's okay. Okay? So let me just draw these triangles again because I think they're kind of important, all right? So we're going to go like this. So this is 90, this is 45, 45. So I would have these kind of drawn in your notes somewhere. It'd be kind of important. Okay, so this is going to be x, and x squared root of 2. And then over here, we're going to do a 30, 60, 90 triangle degrees. This is 60 degrees, 90, 30. And the short leg is going to be x. The long leg is going to be x squared root of 3. And the hypotenuse is going to be 2x. Okay? So those diagrams are kind of important. This is a 45, 45, 90. Oops. 45, 45, 90. This is a 30, 60, 90. Okay, so those are the two types of triangles we're going to want to know. All right, let's put it together here. So there's some words here. We'll just kind of get to this example, all right? So what I'd like to do is basically, first thing that would be a good idea is when you have your triangles, label it based on what model it is over here, if it's this one or this one, and then go ahead and kind of figure out what we have from there, okay? So we're doing a 45, 45, 90 triangle. Why don't let's do number 2 together first, because this one's kind of weird here. Actually, we're going to do 1 and 2, and then you guys will try, then you'll try example 2, okay? So we're looking for this. All right, so we have this triangle right here. We have 45, 45, 90. We have this is 6. So we need to label what we know here, right? Well, the hypotenuse is always across from the right angle. So this is going to be, what's the thing for the hypotenuse here? Well, the hypotenuse is x squared root of 2. And over here, it's going to be 2x. So we're going to label this x squared root of 2. And the legs were both x. I think it's just a good idea just to label them so you know what we're working with here, okay? And then, what do we know? Well, we only know that this side is 6, right? Well, what that tells us is that x equals 6, right? So if x equals 6, what is x squared root of 2 going to be? Well, literally, we're going to take this 6, we're going to plug it in for x, and we get what? 6 square root of 2, okay? All right, so these special right triangles are just a shortcut. With these angles, there is a way to kind of figure out the side lengths without having to use the normal methods of Pythagorean theorem and stuff, okay? Let's do one more. We have 4 square root of 2. And so remember the right, across the right angles, the hypotenuse, this is x squared root of 2. And these are both actually x, okay? So this is a little bit weird here. Let's follow this along here. This is x equals 4 square root of 2, right? So if x is 4 square root of 2, what is x squared root of 2 going to be? Well, let's think about this here, right? So this is going to be, we're going to take this, we're going to plug it in for x, so we're going to have 4 square root of 2 times this square root of 2 is still going to go right here, right? So that one's a little weird because we had an extra square root of 2 in there. And then what is square root of 2 times square root of 2? Well, x square root of 2 is going to equal 4 times, square root of 2 times square root of 2 equals 2, and then 4 times 2 is going to be equal to 8. So our hypotenuse is going to be equal to 8 for this one, okay? All right, that was a tough one. What do we got here? Okay. All right, let's do one more example here. If you want to try this one on your own, you can, but we can just go through this one together too as well. If you want to pause the video and give it a try, go ahead. All right, so we have a 45, 45, 90 triangle. What I would say, too, depending on how these are labeled fine. These are both x, which is good, and this is x squared root of 2. But I would, if the labels kind of mess up the normal pattern of labeling, I would just cross them off and just put what we want, okay? So let's see here. So x squared root of 2 equals 9 squared root of 2, right? Okay. All right. Well, what's the case here? What's x going to be? Well, you can see x matches up with 9. If you want to, you could divide both by square root of 2, and that would cancel them out. Or you can just kind of see that x equals 9, because they kind of line up there. So x is going to be equal to 9. All right, sounds good. Why don't you guys try these next two examples, these checkpoints on your own, see how you do. Okay, sounds good. This is what I was kind of talking about. So we don't like to call this x. This is not x. I'm just going to call it y. I'm going to call this y. And we're going to label our things here. This is across from the right angle is going to be x squared root of 2, and these are both going to be x. So we like to set what we have. We know that this is 2 square root of 2, so x equals 2 square root of 2, and then what we're looking for is y, which equals x square root of 2, which equals, but in this case x is 2 square root of 2, so we got to do 2 square root of 2. Times square root of 2. So that's this square root of 2 matches with this square root of 2. Okay? And the x goes right here. Okay? So now we have x square root of 2 equals, what's 2 square root of 2 times square root of 2? Well, that's going to be equal to, this equals 2 times 2. So x square root of 2 equals 4, or y equals 4. All right, awesome. Next one. Okay, are these labeled okay? Let's see here. These are both x. This is x squared root of 2. So we take what we have and we set it equal. So we know that x squared root of 2 equals 12 squared root of 2. So what is x going to be? Well, x has to be 12. And if you're not sure, you can just, it's multiplied by square root of 2, so we can divide by square root of 2 on both sides. These are both going to cancel. What is this rattling going on here? And then we get x equals 12. All right, sounds good. Now, let's go ahead and do a similar thing, but now we're going to be working with 30, 60, 90 triangles, okay? All right, so what was the model again? Well, the short leg was x, the long leg was x squared root of 3, and the hypotenuse was 2x, okay? So what do we know here? Well, we know that, that 8 equals x squared root of 3. So we're going to say x squared root of 3. Let's see here. These are kind of bad problems, but we'll stick with them. Okay, it's going to be kind of a complicated problem, but it'll be good to get some practice with radicals. So we have x squared root of 3 equals 8, right? Okay, so now we need to solve what x is equal to. How do we solve for x? Well, it's multiplied by square root of 3, so we're going to divide both sides by square root of 3. So we get x equals 8 over square root of 3. Now, what's wrong with this? Well, we do not like radicals in the denominator. We need to rationalize it. How do we rationalize it? Well, we multiply top and bottom by square root of 3 to cancel that out. So that's going to give us x equals 8 square root of 3 over 3. Okay, so that's x. So now we found what x is equal to, which is that, that leg right there. Okay, so that's one of the things. Then we need to find y, which equals 2x, but we're doing 2 times... right? 2 times x, which is 8 square root of 3 over 3. Now, how do we multiply this 2 times this fraction? Well, if with 2 over 1, we multiply across, right? So y is going to be equal to, 2 times 8 is going to be 16, so we have 16 square root of 3, and then 1 times 3 in the bottom is going to be 3, okay? That was kind of a hard one. These ones on your test quiz are not going to be as hard as this, but it's good to kind of know how to do it. Okay, let's do another one. Number 2. So we have this triangle here. This is 60. This is 30. It's an equilateral triangle. Okay, so what do we know here? Well, we know this is the across from 30 is going to be x. The long leg is going to be x squared root of 3, and the hypotenuse is going to be 2x. Okay, so we're looking for, we have a couple things here. We can say x equals 6, which is helpful, or we can say 2x equals 12, and how do we solve for x? Divide by 2. We get x equals 6. So it's basically the same thing. So if x equals 6, what is x squared root of 3 going to be? It's going to be 6 square root of 3, because x equals 6. So that's going to be h. h equals 6 times square root of 3. All right, sounds good. Why don't you guys go ahead and try the checkpoints, see how you do, and then we'll be done with the lesson. All right, the labeling here is all goofy again. We're going to call this x squared root of 3, and we're going to call that z, okay? Because we don't like the x is in the wrong spot. So what do we need to label as? X squared root of 3. 12 is equal to x, and y is equal to 2x. So what do we know here? Well, we know that x equals 12, okay? Which means x squared root of 3 equals what? 12 square root of 3, which equals z, okay? And we know that y equals 2x, but 2x is going to be 2 times what? Let's see here. 2x is going to be 2 times 12, right? Which equals 24, which equals y. Awesome. Last one. All right, so we label this here. This is not right. This should be x. This should be x squared root of 3, called a z. So we're going to have x squared root of 3 up here. Across from 30 is going to be x, and then the 4 is going to be 2x. What side did they give us? Well, they gave us 4, so we know 2x equals 4. Divide by 2, we get x equals 2. And that equals y, right? So y equals 2. All right, and the last one we need is z. And so x squared root of 3 is z. And if x equals 2, it's going to be 2 square root of 3, which equals z. All right, there we go. I think that's the end of this lesson. Make sure you always, go back and rewatch it if you have more questions. Make sure you bring questions to class, study, do your homework. Thank you for watching. Have a great day, and we will talk soon.